People have long dreamed of making machines that think. This is not a new idea. It is an old dream, woven through our stories and our history. For centuries, we have imagined automatons and artificial beings. We have wondered if a mind could be built from something other than flesh and blood. This question stayed in the realm of philosophy and fiction for a very long time. It was a thought experiment, a distant hope. The tools to even begin such a project simply did not exist. The very concept of computation was still taking shape, a ghost in the machine of human thought. The modern chapter of this story began in the middle of the 20th century. A brilliant man named Alan Turing asked a simple yet profound question. In 1950, he proposed a test to see if a machine could exhibit intelligent behavior. He asked, "Can machines think?" This question was a starting point. It gave researchers a goal. It turned an abstract dream into a concrete, scientific challenge. The Turing test imagined a future where the line between human and machine intelligence might blur. It was a bold and provocative idea, setting the stage for decades of work to come. Just a few years later, in 1956, a group of researchers gathered at Dartmouth College. There, a man named John McCarthy coined a new term. He called it artificial intelligence. This name gave the field an identity. It marked the official birth of AI as a formal discipline. The attendees were optimists. They believed a thinking machine could be built within a generation and laid out an ambitious roadmap. Following the initial excitement, the path forward proved to be much harder than expected. The first wave of researchers faced immense challenges. Computers of that era had very limited memory and processing power. The complexity of human intelligence was far greater than they had anticipated. Progress was slow, and the grand promises of the 1950s seemed to fade. Funding began to dry up. Government investors grew skeptical. Private investors grew skeptical. This led to periods known as AI winters. During these years, research continued, but quietly and with far fewer resources. Despite that, important milestones were still achieved. These breakthroughs reminded the world of AI's potential. In 1997, a major event captured global attention. IBM's supercomputer Deep Blue defeated Garry Kasparov. This was a landmark victory. A machine could master a game of immense strategic depth. Deep Blue, however, did not learn like a human. It relied on immense computational power and searched millions of possible moves. It was an engineering triumph, not a thinking machine. In the 2000s, a fundamental shift began. This approach was called deep learning. It was inspired by the human brain and used many-layered artificial neural networks. For years, it was theoretical, held back by lack of data and computing power. By 2015, the world of AI was buzzing with the power of deep learning. A new sense of optimism had returned. It was in this environment that a new kind of research lab was born. A group of influential figures came together to form OpenAI. Elon Musk, Sam Altman, Greg Brockman, Ilya Sutskever. They shared a common vision. They believed that artificial general intelligence, or AGI, could be the most important technology in human history. They wanted to ensure it would be developed safely and for the benefit of all humanity. The mission of OpenAI was unique from the start. It was founded as a non-profit research laboratory. The name reflected an initial commitment to collaboration and transparency. The founders pledged to work openly, sharing research with the world. They wanted to avoid a secretive, competitive race that could be dangerous. Their primary goal was not products or profit. It was to advance digital intelligence to help everyone. This mission attracted top minds. The founding philosophy was long-term. If achieved, AGI might help tackle climate change, disease, and poverty. But the risks were clear. Safety was a core part of its founding charter. Early work focused on reinforcement learning, robotics, and building safe, robust AI systems. OpenAI's research soon began to focus on one of the most challenging areas of AI, natural language. In 2017, a landmark paper from Google introduced the transformer. It excelled at handling sequences like sentences and paragraphs. The OpenAI team recognized its potential and explored scaling it up. They hypothesized that training a very large model on vast internet text could learn patterns, grammar, and nuances of human language. This led to the Generative Pre-trained Transformer, or GPT. The first version, GPT-1, arrived in 2018. It demonstrated the power of the approach. In 2019, GPT-2 captured the public's imagination. From a simple prompt, it wrote coherent, relevant paragraphs. OpenAI initially hesitated to release the full model, worrying it could generate fake news, spam, or malicious content. A global debate about responsible AI release began. The team kept scaling. In 2020, they unveiled GPT-3. The leap from GPT-2 to GPT-3 was staggering. GPT-3 had 175 billion parameters and unprecedented training data. Parameters are the values learned during training. The results were extraordinary. It could write poetry, draft emails, answer complex questions, translate languages, and even generate computer code. It felt like a different class of model. It showed emergent abilities. Recognizing its power, OpenAI made a pivotal decision. They released GPT-3 through an API. Developers could build on top of it. With the success of their language models, OpenAI explored other domains. Could a transformer learn relationships between language and images? Early 2021, DALL-E arrived. It could generate novel images from text prompts. Ask for an armchair in the shape of an avocado, and it would create it. The images were creative, often surreal. This opened a new frontier in AI-driven creativity. These models weren't just manipulating text, they were learning concepts about the world. Next came the language of computers, code. Built on GPT-3, they developed Codex. Trained on massive amounts of publicly available code, it translated natural language into working code. That tech became the foundation for GitHub Copilot, an AI pair programmer, suggesting lines and entire functions. Codex proved AI could accelerate software creation. But the biggest moment was yet to come. In November 2022, OpenAI released ChatGPT, built on GPT 3.5, presented through a simple chat interface. Anyone could sign up and start a conversation. The response was immediate and overwhelming. Millions joined in the first week. People used it to write essays, debug code, plan vacations, and test its limits. The explosive success of ChatGPT marked a new era for OpenAI. It became a major global tech player. Powered by groundbreaking technology, strategic partnerships, and a keen sense of product. Deep collaboration with Microsoft proved essential. Massive investments and vast cloud resources fueled larger models. Specialized processors ran for months. In March 2023, OpenAI released GPT-4, a significant leap in capability, more creative and collaborative, better accuracy and broader knowledge with more advanced reasoning. Crucially, GPT-4 was multimodal. It accepted text and images. Example, a photo of ingredients to a recipe. Vast new applications open, moving AI closer to human-like understanding. Businesses integrated OpenAI models, new startups emerged. Society faced hard questions. Schools rethought academic integrity. Industries debated jobs and new roles. Governments weighed regulation. OpenAI emphasized safety and alignment. They invested in RLHF to make models more helpful and harmless. Pushing tech while wrestling with safety defined its identity. Today, on October 12, 2025, OpenAI stands central in AI. The next steps we take will matter for everyone, for all time.